Thank you for coming. We're delighted to have you here for our third public forum of our new Center for Ethics and Values. We're delighted to have you here for our discussion of neuroscience, free will, and moral responsibility. I am Jessica Pfeiffer, chair of the philosophy department, where the center is housed. Before we begin, I want to acknowledge that UMBC was established upon the land of the Piscataway and Susquehannock peoples. Over time, citizens of many more indigenous nations have come to reside in this region. We humbly offer our respects to all past, present, and future indigenous people connected to this place. And while we recognize the importance of acknowledging those who came before us, we also know that this is a small gesture and we must take action toward the necessary work of repair. The mission of the Center for Ethics and Values is to foster thoughtful, informed, and nuanced exploration of pressing ethical issues we face. Ethical issues are everywhere. We face ethical decisions in nearly everything we do, in our work, in our research, as students, as teachers, in our families, in our friendships, in deciding what to eat, in deciding whether to go to a public forum, in deciding where we get our news, or what shows to watch, or what social media to use, in deciding how to vote, and so on. These public forums provide an opportunity for us to come together as a community, including not only the community within UMBC, but also the wider community UMBC serves, to work together to gain deeper understanding of the serious ethical issues we face. The public forums bring together experts in ethics with those who face these ethical challenges. This event would not be possible without our co-sponsors. Many thanks to the Dean of the College of Arts, Humanities, and Social Sciences, also to the Drescher Center for the Humanities, the Center for Social Science Scholarship, the Department of Biology, the Department of Psychology, and the Human Context of Science and Technology program. And a special thanks to Vanessa Capuano, without whom nothing the center does would be possible. We hope you will also join us at our future events, all at 7 p.m. in this location. On April 8, we will be having a discussion of the ethics of artificial intelligence, featuring one of the architects of ethical AI at Salesforce, a specialist in neurodiversity and AI, in conversation with a philosopher who specializes in A. On May 8th, we will have our annual Evelyn Barker Memorial Lecture featuring Samuel Scheffler, who will be speaking about the existential catastrophe and the love of humanity. More information about these events, please take a brochure, or they're also on the back of your Q&A form, and you can visit us at ethics.umbc.edu. Follow us on social media, or sign up to receive our newsletter. For students in the audience, and sorry, this is only for students, next Wednesday, on March 5th, the philosophy department will be hosting our second Why Philosophy Alumni Perspectives, featuring a student who was in my very first philosophy course I taught at UMBC many years ago, and has gone on to do amazing things. Dr. Michael Nestor. After graduating with a double major in philosophy and psychology, Dr. Nestor went on to get a PhD in neuroscience, and he has since done interesting research related to autism, and also done work in ethics and the use of CRISPR in humans. He is currently the board director for the Government University Industry Philanthropy Research Roundtable, that was a mouthful, at the National Academies of Sciences, Engineering, and Medicine. So if you're a student thinking about majoring in philosophy, minoring in philosophy, doing a philosophy certificate, or already a philosophy major, join us next Wednesday for what I'm certain will be a very interesting conversation with Dr. Nestor. And now I would like to introduce the inaugural director of the Center for Ethics and Values, Professor Whitney Schwab.
Well, Thank you very much for coming for what promises to be a very stimulating, interesting event. So as Jessica said, I'm Whitney Schwab. I'm an associate professor in the philosophy department here at UMBC. And in this capacity, I'm the inaugural director of UMBC's Center for Ethics and Value. So first, just to give an overview of what we're going to do tonight. Roughly the first half is going to be a panel discussion between Adina Roskis and Aaron Scherger, moderated by Steve Yalowitz. That'll take roughly about half the time. And then the second half is going to be devoted to the panel answering questions from the audience. So either you have or you're near somebody who has one of these things. The way to submit a question is to scan the QR code, then enter your questions, and two moderators will be collating the questions, then ask them from the audience in the second half. But you can ask the questions from the beginning of the event through the link, or the code should be live now. Okay, so to introduce our speakers, I'm going to begin with, I guess I'll go in order of proximity to me. So Aaron Scherger is currently assistant professor in the Department of Psychology and the Brain Institute at Chapman University. Dr. Scherger completed his undergraduate studies in computer science at Indiana, and then worked as a software consultant before going on to earn his PhD in psychology and neuroscience at Princeton University. After that, he joined a research team at the Neurospin Research Center as a postdoc, and then as a senior researcher at the EPFL in Switzerland. He went on to join the French National Institute for Health and Medical Research as principal investigator based at the Neurospin Research Center near Paris. Dr. Scherger's research focuses on the neural signatures of subjective experience and the neural antecedents of self-initiated movement. In 2013, he was awarded the William James Prize from the Association for the Scientific Study of Consciousness, and in 2015 was awarded the BMI Calloy Prize from the Calloy Foundation for his work on the influence of spontaneous fluctuations in brain activity on self-initiated movement. Adina Roskis, second to the left, is a professor of philosophy at the University of California, Santa Barbara, where she is also affiliated faculty with the Department of Psychological and Brain Sciences. She received a PhD from the University of California, San Diego in Neuroscience and Cognitive Science in 1995, a PhD from MIT in philosophy in 2004, and an MSL from Yale Law in 2014. That's a lot of school. Prior to her work in philosophy, she held a postdoctoral fellowship in cognitive neuroimaging at Washington University and was senior editor of the neuroscience journal Neuron. Dr. Roskis' philosophical interests lie at the intersection of philosophy and neuroscience and include philosophy of mind, philosophy of science, and ethics. She was a member of the McDonald Project in Neurophilosophy and the MacArthur Law and Neuroscience Project. Her awards include the William James Prize and the Stanton Prize, awarded by the Society of Philosophy and Psychology, a Mellon New Directions Fellowship, and the Lawrence S. Rockefeller Visiting Faculty Fellowship from the Princeton University Center for Human Values. Steve Yalowitz, our moderator, is an associate professor here in the philosophy department at UMBC. He received his BA at Oberlin College and his PhD from Columbia University. His research interests lie in the philosophy of mind, free will, self-knowledge, and psychological explanation. And I'll turn it over to Steve now to get the conversation going. Thank you.
Okay, so what we've done, Adina and Aaron and I have sort of prepared for this a little bit, and I've given them these questions ahead of time so they can think about them. They're the experts on the neuroscience. I'm just trying to bring a philosophical context that allows them to relate studies in neuroscience and free will to traditional philosophical discussions. So we have a few questions prepared that I'll just read from. So the first question, many of the provocative headlines we see in the popular press that claim that neuroscience has proven that free will is an illusion stem from Benjamin Libet's experiments in the 1980s. Some researchers interpreted these experiments as showing that brain activity preceding subjects' conscious awareness of having made a decision to do something actually constituted a prior unconscious decision that caused those conscious episodes. If this was the correct interpretation of the data that Libet's experiments produced, then human decisions, at least in these sorts of experimental contexts, would appear to not be freely made by us. If our awareness of our decisions comes after the actual decision, these researchers wondered how we could be in control of these decisions. So I'd like to invite both Aaron and Adina to talk about those experiments, as well as later ones that followed up on those particular experiments, and their bearing on the question of whether we have free will.
Great. Do you want me to?
You want to start? Yeah.
Let's see if we can. Okay, this is just an example of some of the fairly recent books and papers that have purported to have evidence in them that show that neuroscience demonstrates that we lack free will, or at least raises the question of what neuroscience can tell us about free will. And we actually take issue with many of those, and at least the ones that suggest that we do. So why don't I start out by explaining what the Libet experiments are. So as Steve noted, what Libet tried to do was to look at the time at which you're conscious of making a decision relative to what your brain is doing around the decision-making time. And so what he did was he set people up where they were recording from their scalp with an EEG, and he also measured their muscle activity so he could just figure out exactly when it was that they made a movement. And then he asked them to spontaneously move their finger whenever they wanted, not to plan in advance, but to just freely move whenever you want to move. But in addition to that, he asked them to pay attention to a clock that had a rotating dot on it, and to note when they were aware of the urge to move or the decision to move by noting where the dot was on the clock, so that after each of the trials in the experiment, they could report when they were aware of this urge. And then, given that and the time at which they moved, the experimenter could tell what the brain was doing at the time that they were aware of willing to move. So that's the basic setup of the experiment. And just to show you what it looks like, this sort of round thing is just a visual of the electrodes that are covering your head with a cap. So you're looking at this cap, and the person is asked to perform this task of spontaneous movement. And if you record from one of those electrodes for each of these epochs in which they are asked to move, and you register all of those movements to the time at which their fingers move, so that's the 0 point there, you see that there's a very noisy signal on each of the trials preceding the moment at which they move, okay? And so if you take all of those noisy trials, individual trials, and you average them together, you get something that looks like that, and that's called the readiness potential. It's a very reliable signal that you can produce if you have an experiment that's set up this way and you analyze the data by averaging all the trials at which someone moves to the point of movement. We can see this in many, many experiments, that there's a readiness potential, and it starts a couple seconds before the movement itself. And when Libet asked people to say when they were aware of willing to move, it turns out that that was actually approximately 200 or more milliseconds before the moment at which they moved. And when you look at the 200 millisecond mark and where it is relative to the time at which that trace starts to deviate from baseline, you realize what Libet saw, which was that people's willing to move, or their awareness of the decision to move, came after the signal started to deviate from baseline. So what he interpreted was, the way he interpreted the data was that your brain decides to move before you are aware of that decision. And because of that, he thought our movements were initiated by the unconscious, and our conscious will was sort of epiphenomenal, not really causally effective in causing our actions. And he said, okay, that's evidence that we don't have free will. And he did think maybe we have free won't. That is, maybe there's enough time between the point at which we are aware of this urge to move and the time in which we actually move that we can veto it, but then it with more experiments, it turned out that you can't actually veto it in that time, so we don't have free will. So we're in a pickle. We don't have free will. And this result has been maybe the most widely promulgated neuroscientific discovery about volition that there is. Maybe of all the basic neuroscientific discoveries, maybe the one that most people have heard of. Aaron can, I think, jump in now and tell us like what we should actually take away from this experiment.
I mean, arguably the most infamous rather than famous, and one that people have argued about and debated about for many, many reasons. Not just the ones that I'll go into, but I'll go into my favorite reasons why. So let's see the order of these slides. So this actually goes back to 1965, just as a bit of history. This readiness, what we ended up calling the readiness potential in English, was originally called the Bereitschaftspotential. My German pronunciation is probably terrible, but and it was discovered in 1965 or in the early 1960s by Kornhuber and Deka, who at the time they had the bright idea of thinking that in a typical psychology experiment there's a stimulus and there's a response, and they thought, wait a minute, what if we get rid of the stimulus and we just ask people to just move whenever they want? And they discovered this readiness potential, by the way, using reel-to-reel tape to record the EEG, which they would wait till the moment of the button press and then stop the tape and then flip it in reverse so they could play back onto a separate storage medium what had just happened in their brain. So they discovered this some 20 years before Libet had his idea to add the clock. So I think these, yeah. So a couple of points about the RP. One is that, and this is just from some experiments of mine, but if you look across subjects, so each one of these is a different individual, you can see the incredible amount of variability there is. So it's a very unreliable signal in individual subjects. Although when you look at the group average at the bottom, doesn't it look beautiful? But there are very few of the individual subjects that have anything that looks like what you see in the average. And another important thing to bear in mind is that you really can't see much of this signal right after an individual movement. So what's up on the top is just one trial, and it's just noise. Right? This signal is so weak that you have to average together many trials, 50 or more, to start to be able to see it. So it's really, here it gives you an idea. So the white stuff is all the raw data from the individual trials, and the black thing in the middle is the average. Right? It's a very tiny little signal buried amongst this EEG noise. So here we go. So what my colleagues and I did, this was back in 2012 when we published this, was we thought, well, what if this gradually building signal, what if it doesn't reflect the outcome of a decision? What if it reflects the buildup towards a decision? And that the decision itself, the deciding moment that actually determines that your finger is going to move, happens relatively late in the game, roughly around that minus 200 milliseconds mark when Libet's subjects said they thought they felt they had decided to move. And the story we came up with, right, was based on the observation that your motor system, and in fact most of your brain, undergoes spontaneous random fluctuations all the time, kind of like this trace you see down at the bottom. If you look at brain data from EEG or even invasively recorded brain data, even when you're doing nothing in particular, there's a spontaneous ebb and flow, like gentle waves on the ocean. What if, right, this ebb and flow in the motor system is just ongoing, and when you have no good reason to move, what if you're more likely to move when that ebb and flow is just a little bit closer by accident to the threshold for triggering a movement, right? If that's the case, and you align your data to the moment of the movement, you're guaranteed to recover those random fluctuations in the average, right? And you'll get something that will look to you like the brain was getting ready to move on purpose, right? That the brain had made a decision in advance, when in fact, The decision itself didn't really manifest until that signal had built up to a critical level, right? It was, and one of the important facts about this is that these RP-like ebb and flow is happening all the time, even when you don't move. And one of the ways that, I think we have this slide, yeah, one of the ways that we showed this was we asked people to do this admittedly strange task where you're asked to sit there with a button and your finger on the button and just press the button kind of whenever you want. And don't pre-plan it in advance and don't decide in advance and try to like be spontaneous, which is a weird instruction, right? Surprise yourself in a sense. So we had people doing that task, but we told them, but we're going to add a little different instruction, which is that if you hear a click, you should press the button immediately as fast as you can. Otherwise, just wait and move spontaneously when you want. And what we found there was, what we did was we separated their reactions to the click, to the very fast ones and the relatively slower ones. And what we found is something like the readiness potential building up already. I think it's here. So if you look on the top left, you'll see the fast versus the slow. See something that's already building up in a negative, so this is a negative voltage, so that's why it's going down. So building down if you want. In advance even of the click. So the reasoning here is how, if this signal, if this slow ramping represents a preparation to move, well, it begs the question here, how can you prepare for a movement that you don't even know you're going to make? Right? And in essence, you can't. What this shows is that there's a very different kind of explanation that's needed. It's that these kind of fluctuations are there all the time. They're incidentally related to you making the movement, even though they may play some sort of a causal role, because they affect the probability that you'll move at a particular time. But it doesn't reflect a decision, right? The decision we argued is something that comes much later in the game, very close to the time that you actually move. Around 150 or 200, like 0.2 of a second before you move, which coincidentally is just the time that Libet's subjects reported that they thought they had been aware of their decision to move. So this was a new spin on a new way of interpreting these data that we introduced that's kind of changed thinking about it. And in my mind, I think it throws enough doubt on the sort of classical interpretation that I think we can't really lean on this kind of data anymore as evidence against conscious free will.
Can I add some more?
Yeah. You should just interrupt, I guess. It's supposed to be a conversation.
Yeah. So I think one of the beautiful things about this is that there are pretty standard decision models in psychology, which seem to be borne out in neuroscience, which basically show process of evidence collecting. So if you are looking at, let's say, a monkey making a decision about a task where he has to choose what direction he sees the visual stimulus moving, you can record from an area of the brain and show that essentially the motion of the stimulus is giving him evidence, and when the evidence reaches a certain threshold, he makes his decision and answers or produces a movement to answer the question of the experimenter to get his reward. So that's a standard decision model. We can call it a stochastic accumulator or a drift diffusion to bound model. And what Aaron's work suggests is that kind of model that we use for modeling regular decisions that seem to be implemented in the brain is the same kind of model that can underlie these spontaneous decisions, where the thing that pushes you to the threshold is just the noise that's already there, because in that task you have no reason to move at any particular time. So if you have a decision to make that has no reasons behind it, you can just harness the noise in your system to make that decision. But if you have a decision to make for evidence, you can use the neural signal for the evidence to help drive that decision model. And so one of the nice things is that it unifies the way in which we think about decisions for reasons or decisions for evidence and these spontaneous decisions that don't happen for reasons.
Yeah, so I guess that was an important part of the description, was that it leaned on this existing model for how decisions were made. And it says when you make decisions, even in a weird task like this, like Libet's task, the mechanisms that involve might be the same that are involved when there's a stimulus, except that now the noise takes over. It takes more of a role than any kind of a stimulus. So that I don't have it up there, but in this kind of model, there's a term for kind of an impetus, which is usually assigned to the stimulus, and there's another term that introduces noise. And that gets integrated over time or accumulated over time until it reaches a boundary, and that's when you take the decision. And all we really had to do to get this model to nicely fit the behavioral data was to set the parameters so that the impetus was very, very weak, and it was mostly being driven by the noise. And that worked very well in fitting the brain data and the behavioral data from subjects doing that task. And we linked, there is still an impetus in this model. It's not just noise. The impetus is sort of white coat syndrome in a sense. So it's what we call in psychology the demand characteristics of the task. Even though I don't wear a white coat, when people come into my lab, they still know I'm the researcher, and they've come to do an experiment about moving and pressing buttons. And so when I tell them there are no rules, and I tell them you can just press the button whenever you want, just whenever, I'm not going to tell you when, implicit, right, even though I tell them that, even though in theory they could wait an hour, they could wait till tomorrow, they could never move the whole time and then just leave and get paid, they never do that. Because they know it's just implicit, right? I'm expecting him to press the damn button now and again, right? And so they do it. And nobody ever waits longer than about 30 seconds to press the button on each. So there is a little impetus there. It's not zero, but it's small. And when you have no good reason to choose to move now instead of later, on what basis, right, do you choose?
Yeah. So thinking about this model, I mean, one of the things that falls out of the model is if you run this decision model over and over again, and you time lock everything to the moment at which you cross the threshold, you get something that looks like an RP. And what that suggests is, if you look at what happens in individual trials, there's really no reality to the fact that there's a deviation from baseline. It's going to happen as a result of the way you've decided to collect your data and analyze your data, but it's not reflecting any real physiological signal in the system. And so all of these experiments or interpretations of the experiments in which, like Libet and other people who follow him, say, oh, but look, the deviation starts before you've ever willed it, are mistaken on numerous grounds, because it looks like on the alternative interpretation, you don't actually will it until you're approximately aware of willing it. But also the brain activity isn't starting at that point. It's an artifact that you've created by the way you've done the experiment. And so I think all of the classical views, the classical Libet interpretations have to be discounted. And so I think this kind of neuroscience doesn't give us any reason to question whether we have, whether our wills are causally efficacious, whether conscious will is doing anything. So I think that it's a really important result, at least philosophically speaking, if you think that consciousness has to precede freely willed actions.
Yeah, and I mean, there's been subsequent work after Libet's work in the 1980s that seemed to corroborate that whole story. I mean, the classical Libet type story. So in 2011, there was an important study that came out, basically doing Libet's task, but with patients who had electrodes implanted in their motor cortex in their brain, in various parts of their brain actually, premotor cortex areas, an area called the SMA and the pre-SMA. And they were able to find basically the same kind of result as Libet. You get this gradual buildup that starts a second or two before the movement when you ask them to move spontaneously. That just showed that, okay, you can get this same thing at the level of individual neurons. It's not just a quirk of recording things at the scalp. But this same explanation that I've offered applies. It doesn't really matter how you measure it. The same explanation applies. One important thing, again, is to look at what's happening when you don't move. And that's what nobody ever did in the field. The way research went in the field was, well, what do you do? How do you know what data to look at? Well, when the person moves, you look at the data right before that. So as a consequence of that strategy for picking out the epochs or the little bits of data that you look at, you're not going to ever look at what's happening in the brain when you don't move. And as a consequence, it's kind of like trying to convince somebody that you know how to predict the rain when you've learned that based on a sample of rainy days. Right? That won't work if you go out into the real world and start trying to predict rain, because lots of times it doesn't rain, depending on where you live.
One follow-up. Dina had mentioned evidence or reason-based decisions as opposed to these kinds of spontaneous decisions. So when in the brain activity that you see prior to a reasons or evidence-based decision, do you get the same kind of curves representing activity with the same kind of dip just before the decision is made?
Well, there haven't been as many studies looking at that, just a couple. One of them by my colleague Uri Maoz has showed, yes, that when you're making a movement that's consequential, that's for, in a sense, that's meaningful or for a reason, that readiness potential seems nowhere to be found, in a sense. It's very weak or even, you might argue, absent.
So the activity that's going on in the brain at that point is correlating with deliberation about the relevance of evidence or bearing of reasons.
I mean, it's hard to know when you're doing EEG, it's very hard to know what it is that you're recording. What I was going to say is that there are studies where essentially you're doing perceptual decision making, right? And the perceptual evidence is the evidence, and what you see is that there's a very sharp, when you have strong evidence, there's a very sharp rise to the point of threshold. When you have weaker evidence, it takes longer for you to get to threshold. And then when there's zero evidence and just noise in the system, it's very slow to get to threshold. And sometimes the monkey moves one way and sometimes the monkey moves the other way. So it's what you would expect if you had that very same kind of system, but you were twiddling with the strength of the evidence, right? Mm-hmm. So you get the slow rise to the ready potential in the cases where there's no evidence, and you get a much faster slope when there's strong evidence.
Okay. Well, in the next couple of questions, we'll probably come back to the Libet experiments and work coming after, but I'm going to move to a different topic or related topic. So the primary threat that philosophers have identified for the idea of free will has come from the claim that, at least in its macro processes, the universe, and therefore our brains and our bodies, is deterministic. So we can assume that determinism, for our purposes here, means that there are laws of nature that, together with initial conditions such as the Big Bang, entail all future events. That's the way determinism is typically represented in the philosophical literature. Since our decisions are in some sense realized in our brains and our actions are realized in our bodily movements, determinism seems to entail that human thought and action have to occur as they do given the laws and the initial conditions. So we have this picture that determinism entails that what you do or think, you have to do or think. That kind of deterministic picture has been taken to threaten human freedom due to the idea that if our thoughts and actions have to occur, then have to occur as they do, then we cannot think or do otherwise than we do on any given occasion. And if we can't think or do otherwise, then we lack a kind of control that seems to be built into the idea of freedom. This is a forward-looking picture of how determinism threatens freedom. On this view, determinism prevents us from having more than one possible future, and that's why it's inconsistent with free will. Some philosophers more recently have identified a different sort of threat that they claim determinism poses to freedom. That if our thoughts and actions derive from factors beyond our control, for instance, the laws of nature and the initial conditions, then just by virtue of that fact, we lack freedom. On this view, we're not in control of our decisions and our actions if we're not in control of the factors that bring them about. Let's call that a backward-looking picture of how determinism threatens freedom. Backward-looking because it focuses solely on the history preceding the thought or action. And people pressing this kind of threat to free will do so because they're trying to avoid difficult questions about the ability to think or do otherwise. For instance, some philosophers, actually many philosophers these days, think that having an ability to do or think otherwise isn't actually necessary for freedom, or, and this is quite a popular view, that such an ability to think or do otherwise is actually compatible with determinism. So I'd like to ask both Aaron and Adina to address these different forward and backward-looking pictures of how determinism threats freedom in the context of neuroscience and in the context of these sorts of experiments.
Great. So there's a lot there,
Yeah.
and I guess what I first want to say is that there are philosophical views that take issue with the assumption that determinism is undermining of freedom. So there are a variety of different views. Let's see if I can find there, that essentially pit freedom against the truth about determinism in the universe. And so there are what are called incompatibilist views. That is essentially saying that freedom is incompatible with determinism being true. But then there are two possibilities. One is that determinism is true and you don't have free will, but the other possibility is that determinism is false and then you do, or at least can have free will. So there's that's the libertarian view, is that indeterminism is true and in virtue of that you have free will. And then there's a view that just rejects the notion that determinism undermines free will at all. So it's a compatibilist view. I myself am drawn to the compatibilist view, although I can, see why people are very persuaded. I think, the average person coming to this problem will think it's very compelling that if determinism is true, we can't possibly be free. I think that the compatibilist picture is one that's really appealing, but in order to get it, you got to put on different glasses. It's like you have to totally change your perspective on the world and what you expect. And one way that I can at least motivate that idea is that, okay, let's just go along with the notion that if what you're going to do is determined, then you're not free. But then what if the opposite is true? What if indeterminism is true? Well, let's say every time you wanted to make a decision, somebody had to flip a coin, and that was what you decided. But that doesn't seem like what freedom is either, right? So if indeterminism is true, if what makes your decision the case is some blip in the universe, that doesn't seem like a good basis for freedom either. And so neither of those seem like a solution to the problem, yet it seems like a real open question whether or not we're free. And one way that I can try to motivate the thought that maybe determinism isn't where the crux of this is at all is by considering a scenario in which suppose determinism is true, and suppose that some supercomputer that knew everything about the state of the universe in your brain could predict what you were going to do. And you had this terrible problem. You were really torn about what to do in that case. Well, this computer can predict what you're going to do. So instead of wrestling with the problem, you could go ask the computer. And the computer would know. But as soon as you asked the computer and got an answer, that would change your brain state in such a way to make that answer completely irrelevant to the question. You could not use that computer to guide your action. And so you are in a position as an agent of having to decide for yourself regardless of whether determinism is true or not. And that position of agency, I think, is part of what makes us free. It's the fact that we have to choose. There is no way out of the dilemma at any point where we have a choice to make, which is essentially all the time. We have to make a choice, and it's our choice that we make. And that's why I think a compatibilist view is the right way to look at it. We are never absolved of agency. And we don't know what it is that we're determined to do if we're determined to do something. And in fact, what makes it the case that we are determined to do it if we are is because of exactly who we are in exactly these circumstances. And it's just the fact that this is what we would do that makes it the case that it's what we're going to do. So it's not that we're predetermined to do anything. It's just that given the way we are and the reasons we have and the situations we're in, this is what we're going to do. And so that's why I think determinism isn't really where we should be looking when we're wrestling with the problem. I think a compatibilist view is right, and then the question is, can you build up a picture of what freedom is in a way that it doesn't hinge on this question of determinism? And I guess I'll get back to that a little bit later, but I want to give Aaron a shot.
Isn't that also predetermined, that you're going to build that computer and that you're going to look at it and that the results you're going to see, and that's all predetermined as well? Or is it that if you look...
If determinism is true, then
right,
yeah, all of
that would already be predetermined. So how does the act of looking at this computer's prediction and maybe acting on it, how does that give you any more agency than you had before? Unless knowing about the future maybe causes some sort of a...
No, my point is you can't know anything about the future that can actually help you in the moment. It doesn't get you out of choosing. So there's no amount of knowledge about yourself that you can rely on in order to choose, because as soon as you want to use that knowledge, you have already undermined that prediction. You have changed the system in a way that the prediction that it gave you is not, so I'd have to, have it recompute everything and then try again, and it would again undermine that next decision. So that it's not that you have that knowledge, it's that even if determinism is true, that information would be unusable by you as an agent.
I take it that Aaron's point is that you just, in that kind of thought experiment, you've changed the initial conditions. But it's still the case that if determinism is true, whatever the initial conditions are, those together with the laws of nature will entail what you choose. And it's not, so the relevant issue isn't whether...
But that's just what determinism is, right? That's
just
right.
Right, but that doesn't address the issue. So the fact that you have to weigh your reasons anyway and decide what to do, that by itself doesn't show that that determinism is either consistent or not consistent with free. Okay.
But it just means that it's practically irrelevant to being an agent.
It's useless, yeah. I think that's actually, I think, an important thing to realize. Whether if indeterminism is true, you still have to make a choice. If determinism is true, so walking around as an agent isn't going to change under these sorts of different metaphysical schemas.
That's right.
Yeah.
But bringing it back to determinism and the question you asked about neuroscience, I think that that neuroscience is not going to answer. So, let's just assume that the question of determinism is open. You suggested in a way that we already knew that determinism was true, but I think we have no idea whether determinism is true. It is an open question, but I think it's not a question that neuroscience is going to give us an answer to. So one way of glossing this is that the only handle we have on determinism is predictability. How do you tell if something's deterministic? Without knowing what the governing equations are antecedently, right? I can make a deterministic mathematical system by choosing those equations, but if I'm looking at a system and I don't know the equations, the only way that I have access to it is by seeing whether my theory about how it works predicts it. Like if I have an idea of the laws and the state of the system, I can see, can it predict it? But we have the problem that predictability cross-cuts the metaphysical truth of determinism. So we have systems that are unpredictable but deterministic. So chaotic systems follow deterministic laws, or at least there are chaotic systems that follow deterministic laws, but you can't predict them, and so you can't use predictability as a way of determining whether they are deterministic or not. And then we have systems that we think are probably indeterministic, like quantum mechanical systems. So the dominant interpretation of quantum mechanics is that it's an indeterministic, fundamentally. Yet, for most of reality, we predict it very well. It's very predictable at a macroscopic level. And so you can have highly predictable indeterministic systems. And so that's one reason why I think just looking at brain data is not going to tell you about the truth of determinism. I think whatever is going to tell you about the truth of determinism, if there's a way of answering that question, is going to be our best physical theory. And that's a question for physics and not neuroscience. Neuroscience operates at a different level. So I don't think if the question is what can neuroscience tell us about determinism, I think really nothing. At least practically speaking. I mean, I can concoct these thought experiments where I could gain all kinds of knowledge of the way brains work that I know is not possible to gain all at the same time. Maybe in that case I could get a little glimmer, but I'd still have the problem of cross-cutting. So I don't think that neuroscience is going to give us any insight into determinism. I do think it can tell us certain things that are relevant to free will, but those aren't questions that bear on this, what philosophy has taken to be sort of the crux of the free will question for a long time.
So, does that mean that these sorts of experiments that we've been talking about, it sounds like there was an element of predictability to the readiness potential.
Yeah, and I think, I'm not sure that neuroscience has nothing to contribute to questions about determinism. I don't think neuroscience is going to, I don't think the decisive evidence is going to come from neuroscience. These are questions for physicists. But some of the evidence from neuroscience can certainly be suggestive or can make you wonder if we can't do this, but if I could predict your behavior at, perfectly a few seconds or a minute in advance, we'd have something to talk about that's suggestive, just as if I found out that the brain as a system is much harder to predict than we thought. That might give us a hint about determinism or indeterminism.
Maybe.
So
I think you'd need to really be able to predict in advance without any. Without error.
I don't know, fair enough, and we can't do that yet. And,
right. I just think we can never do that. Like there is no neuroscientific techniques even on the horizon that would allow us to know all the things that we would need to know in order to do that. And that said, I could predict that you would be here tonight. I can predict all kinds of amazing things about you as a biological system by completely ignoring your biology, right? But instead paying attention to your mental states and what I know about, social structures and pressures to live up to your promises and things like that. And I think that predictability is true regardless of whether you are a deterministic or indeterministic system, right?
Yeah, it's like predicting that any one of you in the audience here is going to brush their teeth before you go to bed at night tonight, let's say. I don't see how that undermines your free will. So there are a lot of things that we can predict. The question is, what about the residuals, and is that true for every act you perform? I don't think so. And at the same time, the ability to predict, whether hypothetically or in actual fact in neuroscience, that's been at the core of all the arguments so far from neuroscience about free will have all been couched in terms of prediction. I can predict what you're going to do before you even know what you've decided to do. Well, that's the claim, right? That's the same in a sense with Libet's task, although he wasn't actually making predictions, but showing that there's this buildup suggests, right, subjectively when you look at it, that, I could in theory maybe use that to predict. So it's that same kind of argument. And there have been more recent studies using fMRI. Say we can quote unquote predict what you're going to choose to do in 5-10 seconds from now, before you're even presented with the choice. But does that undermine free will? Well, no, you have to pay attention to the details. A coin toss, it's a binary choice. Flipping a coin will get you correct 50% of the time. You'll be correct just by accident. Well, they were correct 58% of the time, right? So it was significantly greater than a coin toss, but it wasn't high enough to convince, well, not me at least, that was actually a decision, right? It would be strange if the background conditions for your upcoming decisions weren't present at all in your brain. But how predictable a brain is remains to be seen. I always say that a single human brain is arguably more complex than the entire Earth's atmosphere. And I can explain why for those who are interested. But and we have trouble predicting the weather more than 3-4 days in advance. So what makes you think that you're going to take a deep neural network or any other kind of AI and suddenly predict your behavior far in advance? I have my doubts. I mean, you could prove me wrong, go do it, but...
Maybe this is something we can return to in the question period. I want to move on now to some questions about consciousness. So in the Libet experiments and in subsequent research into the neuroscience of decision-making, conscious awareness has given a kind of primary role in addressing the issue of free will. This suggests an underlying assumption, which is that free choice and action presuppose conscious awareness of at least some of the deliberative processes that inform them. Now, that kind of assumption about conscious awareness being necessary for freedom may be right, but it's not obvious, and it's especially not obvious given that many of the overt actions, which is how we primarily talk about freedom in the real world, many of the actions we hold people responsible for, and therefore in some sense think of as free, don't appear to have been preceded by any explicit conscious awareness. Perhaps a general capacity for conscious awareness of our deliberative processes is a necessary condition for free choice or action, but conscious awareness of deliberative processes isn't required, it seems, in each case of a choice or action for it to be free. So what I'd like to do is ask you each if you could talk a little bit about the question of whether conscious awareness is a necessary condition for free choice and decision-making in the context of how neuroscience investigates these matters.
You want to start, or me again?
Yeah.
Yeah, so I think you're right that there has been, probably just because of the Libet experiment, an assumption that you have to make free choices consciously. And I think I don't buy into that assumption necessarily, although I don't think I have settled views on exactly where consciousness comes in. So I think it's pretty clear that things that have no consciousness, like an alarm clock or something, that doesn't make free choices. So possibly you have to have the potential to be conscious in order to even be a candidate for attributing free will to. And then there are instances where people do things while sleepwalking, and we typically don't hold them responsible for doing those things, maybe because they're not conscious, maybe because they didn't do it intentionally, maybe to be considered to do something intentionally, you have to be conscious. But what I really take issue with is the idea that you have to be conscious of your decision in order to act freely. So I think, and Aaron and I believe
beforehand,
agree.
you have to be conscious of your decision. What you're saying is you don't necessarily have to be conscious of your decision right before the action.
That's right.
Yeah.
The decision maybe must be available to consciousness, but I do a lot of things, I think, freely, like stop at red lights without thinking, now I'm going to stop at the red light. I think I'm still doing that freely. And if something happened that would make that inappropriate, then I would become aware of it, right? So it could be something that could enter my consciousness if things were not going the way I intended them to. But it doesn't mean that everything I do in order to be considered a free action has to stem from a conscious decision. I also wanted to point out that the Libet experiment, the way it works, it's asking you not about, I mean, it purports to be talking about conscious decisions, but in fact, when you are reporting when you're aware of deciding, that's actually a meta-conscious state. It's a consciousness of a conscious decision rather than just a conscious decision. I think stepping on the red light when you see the red light is a conscious decision. You're making it because you're conscious of the red light, but you're not conscious of having made that decision. And I don't think that requiring consciousness of having made a decision or even consciousness that you're making a decision is required for an action to be free.
But as I understand the Libet experiments and ones that Aaron has done after, in a sort of post-Libet environment, the way the experiments are constructed requires, call it consciousness or metaconsciousness, but it requires awareness of something going on.
That's right.
Right, and so I guess the point of the question is, since that's how those experiments work,
Yeah.
and there's an open question, which I think the three of us share, about whether you need to be conscious in all cases in which you act freely.
Right.
How do you bring these two things together? The way we think about freedom not requiring consciousness in every case in everyday life, and the way these experiments are looking into the sort of mechanics of decision making.
I think it's hard to overstate the importance of consciousness. It's just, and at the same time, I agree with Adina. That doesn't mean that in every instance of performing a free act, you had to have been conscious of your decision, and then comes the action, right? But that consciousness will I do think that consciousness will necessarily always be involved, even if it's not before the fact of acting. And sometimes it is. It depends on the time scale. The decisions you make about what you're going to do tomorrow, it seems not too much of a stretch to think that your conscious decision came before you enacted the decision, right, in terms of your actions. So, and I think there are a couple of anecdotes that always stood out for me, and they have for as long as I've been doing science. And one of them is the story about blindsight. And for those of you not familiar with blindsight, some people who have had brain injury to their visual cortex, at the back of the brain, they lose the ability to see in a certain part of their visual field. And this is not due to anything wrong with their eyes, but it's due to damage to their brain. So it's equal in both eyes. But in the case of a patient I've worked with, for example, everything to the right of whatever he's staring at is now gone. Right? There's no sight there. And yet, the famous thing about blind sight is that you can present stimuli there that are in that blind part of the field that the patient denies seeing and has a very legitimate reason for denying seeing. You can look at his brain scan, that visual part of his brain is gone. And yet if you force them or goad them into guessing, they end up guessing correctly most of the time, and they don't know why. So there's some sort of spared pathway for visual information that for whatever reason doesn't give you the feeling of seeing. And you can tap into that by guessing. So that's blind sight in a nutshell. There's a lot more to it. But the interesting thing about blind sight and consciousness and action is that in every blind sight experiment that's ever been done, you have to tell the blind sight patient when to guess. When. So you present a stimulus and you have to play a little beep or something that he is conscious of. Then he knows, now I have to offer a guess, and I offer one and I'm mostly correct. But if you don't tell the blind sight patient when to respond, they won't respond ever, right? If you say, imagine me telling you, when the invisible stimulus appears, raise your hand. We can try that right now. When the invisible stimulus appears, raise your hand. Right? So you don't know when, but I could, if under certain circumstances, I could say, okay, I just showed you an invisible stimulus. Tell me if you thought the bar was leaning to the left or leaning to the right. You could do that, right? You could, well, I'll just have to guess, and there you go, you guess. So initiating action and consciousness seem to be bound together in a very special way. That said, that doesn't necessarily mean that the conscious decision has to predate the initiation of the action, but it's got to be in there somewhere, right? We were talking about earlier about swinging at baseballs, and how that probably is something that you initiate. You can probably initiate the action before you're aware of the trajectory of the ball in the air. Because if you, I'm not a baseball player, but my assumption is that thing is moving so fast that if you wait to integrate its trajectory in the air, it's just way too late. You'll never hit it, right? So some of those processes have to play out unconsciously, but that doesn't mean that the baseball batter swings the bat and then thinks to himself, gee, why did I just do that? Right? Consciousness comes into play, but if you look at this thing in super slow motion, you see that the order of things might not be quite what you had in mind, but consciousness is necessarily involved at some level.
Yeah. I think we should probably move on to Q&A now, given that and so Whitney and I will
Two questions.
take turns asking questions that have come from keep asking, we're going to keep trying to answer as many as we can. So the first question I have is one that someone asked about whether some people can have more free will than others. Is it the kind of term something that can come in
Great.
Without having a good reason to assert this, I believe, yes, that there are degrees that you can learn or practice in certain ways that will lead you to have more free will, but that's just my personal opinion. I don't have any data.
I have a story on
You have a story. Okay.
So in a compatibilist picture, the compatibilist view that I favor, I'll call a capacitarian view. It is that having certain kinds of capacities is necessary for freedom, especially the kind of freedom that underlies things like moral responsibility. These are capacities that I think humans have. I don't think dogs have, but I think dogs have a certain kind of capacity that allows them to act freely in certain domains. So what do humans have? Well, among other capacities, they have the capacity to understand morality. They understand right from wrong. Dogs, I don't think, understand that, or at least not human morality. But they do understand where the, dog dish is and that they should not poop in the house and stuff like that. And they can freely decide if they want to go eat the food, or if they want to leave the food, or if they want to, soil the house or hold it in. I think that is up to them in a way that that is grounded in the fact that they have certain capacities, and children don't have the same capacities as adults. And so I think the really big question for a compatibilist view is what exactly are the capacities that matter? And I don't know exactly what capacities matter, but I think among them are the ability to reason, the ability to control yourself or inhibit responses that are not in line with your values, the ability to represent your values, the ability to move in terms of, can you, I don't want to say that people who can't act have no free will, but their space of potential willed actions is much limited. So the kinds of capacities that you have, bodily control, et cetera, are the capacities that sort of define the space of free will that you have. And so I think that's part of the reason that the law, for instance, takes a view of, the law takes a capacitarian view, and people are not held responsible for things if they, for instance, were unable to understand the difference between right from wrong, or if they, due to damage or defect of their brain, are unable to control certain behaviors. And so it's that kind of capacitarian view that I think really underlies our sort of common sense notion of what it is to be morally and legally responsible. I think that also is approximately the view that defines what the space of free will is. I can't freely will to fly. I can freely will to walk across the room, et cetera.
I'll just mention briefly that they're in philosophical discussions, not sort of tracking neuroscience. There are philosophers very influenced by the existentialist tradition who claim that there are degrees of freedom, and you're at your most free when you are making decisions that you have never confronted anything like those kinds of decisions in the past, and in particular in cases of decision making where fundamental values of yours conflict and you have no settled decision procedure for settling that kind of fundamental kind of incommensurability of value, but you have to make a decision. It's in those kinds of cases that you act most freely, because it's in those kinds of cases that you are not relying upon your previous experience. You have to sort of create yourself. This is actually a term that Robert Kane uses. You have to form yourself, who you are, by making a decision based on reasons which are not really sufficient for making the decision. And that goes back. There's a long existentialist tradition going back to people like Sartre and Camus that sort of inform that kind of thinking. There is an interesting question whether that sort of picture of degrees of freedom ultimately requires some kind of indeterminism in decision making. But I think you can kind of make sense of that idea of degrees of freedom. So people who just go through life making the same kinds of decisions over and over again and don't really confront dilemmas or crises, we might think that they have a much easier life, but in some sense on this kind of picture, they're less free than people who are confronting crises on a regular basis. Something to think about.
Okay, so our next question is on. Our next question asks, do you think free will is something that's acquired, right? Is it something very young children lack and is acquired? If so, what's going on in the development that brings free will with it? What developments the radar have that would bring that with it?
Should I go again? I feel like I'm always going first.
I'll say a short thing. I mean, insofar as what we think of as free will involves what we call cognitive control, which is the domain of the frontal lobe and in particular the prefrontal cortex, then for sure, right? Because that is something that develops and through development, through childhood and even into adulthood. One of the hallmarks of cognitive control is being able to inhibit some otherwise prepotent response in the interest of doing something else that is more important in a maybe longer term, but not as immediately pressing. For example, you're hungry, but you don't eat because you have to go fetch firewood, otherwise you'll freeze tonight. So you inhibit the act of eating in order to do something else that in the longer term is going to help your survival. That's the gist of cognitive control, and that's a capacity that develops into early adulthood. That overlaps a good bit with what we think of as free will, and so in that sense, I think it is something that you can develop and you can even refine and hone. Right?
Yeah. I guess I would echo that and say there's a lot of things, cognitive control, motor control. I mean, infants don't control their limbs and they have to learn sort of how to hook up their muscle movement with their intentional representations. And so, you know, a very young infant can't even reach for something that it wants, and it has to learn those things. And so I think both in terms of representing or developing the representational repertoire to have intentions with certain contents and being able to initiate and control the actions in order to do the things that you intend to do, those things develop over time.
So we have a question about Sapolsky's book. Sapolsky says that the prefrontal cortex is the part of the brain the most removed from determinism because it can adapt to change. Where would you say consciousness is most strongly found in the brain?
I mean,
Other related issues to
right. Well, the question you finished with, like where consciousness is most strongly found in the brain. I mean, that's something that over the recent 30 years or so that there's been a resurgence in research on consciousness, we've come to realize through experiments, but also just logical arguments that there isn't some place in the brain where consciousness is. That I mean, there are certain, for example, you maybe don't need your brainstem to be conscious, although you need it to keep you alive. But by and large, the brain as a whole, and in particular the cortex, is involved in us being conscious. And it's hard to say, well, if I take this or that bit out, am I going to take out the part where consciousness happens? So we tend to associate it with swaths of prefrontal and posterior parietal cortex more than other areas. So if I were to venture a guess as to roughly where, I mean, because for example, the patient who has damage to his primary visual cortex, he's lost consciousness of visual information in that part of the space, but he's still conscious, right? So there are some parts of the brain that seem not essential to generally being conscious, but beyond that, it's really hard to say, and it's almost not the right way to think about it, to ask where is the seat of consciousness in the brain.
I guess the other thing I would add is that there are multiple inconsistent theories of what consciousness is, and each one has kind of a different story if they were to answer that question. I mean, there are some who think, oh, it's actually this posterior area that's really essential, and then there's others that say it doesn't really matter as long as there's a certain kind of connectivity, and then there's another that says that, well, actually there's different kinds of consciousness, and the brainstem is important for a very basic kind of sentience, and then other more complex representational things are cortical. And so I think we are at a point with consciousness research where we don't have any idea what the right theory is, and each theory has a kind of different set of commitments.
Yeah, unless you're the theorist. Like if you're the theorist, then you know what the right one is.
So another question asks, does research in this area have any relevance
That's a really good question.
Yeah.
I mean, I'm tempted to say not yet, but at the same time, I would say I would hope that one day it does, that this kind of research could be useful in that sort of a way.
Yeah, I guess, looking forward, I'll go back to the capacitarian view, right? If that is the right kind of view about what freedom, free will requires, then if you have a theory of what those capacities are, you can think of them as capacities, as functions, or certain kinds of dispositions that are housed in the brain. But then the question is, well, where, what neural systems serve those? And you might be able to identify certain things that could go wrong with those neural systems that could inhibit your, proper functioning, and affect the quality of your will or something, once, enough neuroscience has been done. So I don't think that it's like in principle not relevant, but I think that we're far from knowing what we need to know about the brain and having a properly fleshed out theory of what those capacities are.
I mean, I think, just to add one little bit, I think there are, for example, there's an association with people who experience OCD. They experience a diminished sense of freedom. And I suspect that in at least severe cases, that can be helped by deep brain stimulation and TMS, both of which have been used to varying degrees of success to help people with OCD. So that may be like an inroad.
So we have a couple questions about the connection between free will, moral responsibility, and also legal responsibility. If you could say anything about how those things.
Okay. So I think that the reason that we care about free will is largely because we think that it underlies responsibility, that we can't be held morally responsible for something that we didn't freely do. So if somebody holds a gun to your head and makes you do something, we think that's an excusing situation. You're not going to be morally or legally responsible for something like that. So we want to at least not hold people responsible for things that they didn't do voluntarily. And at least a lot of theorists think that the voluntariness has to be really, the robust kind of free will. So that's, I think, why we care about it. Legal responsibility largely matches moral responsibility in a lot of domains. I mean, particularly criminal responsibility. So we also think that people's mental state is relevant to whether we hold them morally responsible. If you didn't do something intentionally, if you trip over the dog, you shouldn't be held morally responsible for that. Even the dog doesn't get mad when you trip over the dog. So animals seem to actually be able to make some of these distinctions. So we, knowing what having some kind of window into what the brain states are that underlie people's mental states is one of the ways in which neuroscience might have something to say about free will and responsibility. But then I think legal responsibility deviates from moral responsibility in certain ways. So a lot of the law is just set up in order to make society run well. There are kinds of acts that are for which you're held strictly liable, like running a red light. If you say, "Officer, I didn't mean to do it," he's still legitimately able to give you a ticket because it doesn't matter what your mental state was, you did the act. So there are distinctions between moral and legal responsibility, but I think largely our legal intuitions track our moral intuitions. And I think that I don't think that there's any neuroscience that's going to none of the law is written in terms of free will. It's, there's no criminal law that said if so and so did something, without free will, then they're not responsible. But what it does talk about are these capacities that I mentioned. If they don't understand the difference between right and wrong, if they didn't have a guilty mental state, if they were unable to conform their behavior to the law, if they had an irresistible impulse, those are the sorts of things that the law seems to require. And there is a future neuroscience where maybe once we understood what the neural systems were that subserved these kinds of capacities, we could also say in like difficult cases whether somebody really was unable to resist doing something at that time because they had a certain kind of brain damage. But I don't think that there's any neuroscience that's going to say, oh, there's no free will, so nobody's responsible for anything, right? That's not one of the possible avenues in which neuroscience can affect the law.
I'll add a slight wrinkle. It's not necessarily inconsistent with what Adina just said, but there are normative considerations to, certainly to legal responsibility. So you're responsible for, you're legally responsible for things that you should have known were against the law. I mean, this is actually quite an amazing burden that we all walk around with. None of us knows the entire set of laws that sort of govern our society, but you are, strictly speaking, legally responsible for knowing those things. And if you break a law that you're not aware of, that doesn't get you off the hook. So that's a normative constraint.
Depends on the laws, right?
What's that?
It depends on the law.
Yes, but I mean, but this is often the case. I mean, if you park in a spot that's it's illegal to park in,
Yep.
you weren't aware, if there was proper signage, but you weren't aware of what counts as a holiday or whatever it is, that's not going to get you off the hook.
Yeah, I tried. It doesn't work.
So the point here is that there's a kind of a social component to responsibility that it's not that there can't be neuroscientific correlates to sort of social knowledge, but there's quite a large gap between them. And then there's an ought aspect to responsibility that it's going back at least to Hume is hard to sort of relate directly to how the brain actually works. So I myself see a gap between those two.
Wait, so you're saying ignorance of the law is no excuse?
Is that an excuse?
Exactly.
So we had a series of questions asking issues around the limit studies and those kinds of studies. About, a lot of them are asking is like, is there other data around these other issues? So I just want to ask one, and then maybe if we have time, there's more. So there were a couple who were especially interested in whether or not in these kinds of studies, differences in either the topic or importance or like something about like, what the person is deciding about show up in any different ways in their brain activity. If it's a sort of weighty decision, do we see any difference, or is it look roughly the same topic neutrally?
So, I mean, all the limit studies are really decisions where there is no reason, right? There's nothing that hangs on it, but...
So the broader, is there data out there that suggests there is a difference in how our brains operate depending on, especially if you feel how morally weighty?
Yeah, so you want to talk about URIs?
There are very few. To my knowledge, I think there are at this point two. One of them I know pretty well, which is my colleague Uri Maus did the study where people had to press buttons to enact decisions that sometimes had a consequence, which was that a relatively large sum of money might be contributed to a charity that you prefer, versus pressing the button in a case where it didn't matter what the button press didn't change the consequences at all. And interestingly, mainly he found the readiness potential for the decisions that were just meaningless, that had no consequence. But when a decision was consequential, meaningful, then the readiness potential was largely absent. So there is at least some data on that.
And that could be either because the evidence, in those cases, the reasons that people are weighing make the decision behave like a reasons-based perceptual decision, so you have a very quick ramp.
Right.
Or it could be that it's just being, those kinds of things are being processed in a different part of the brain. So it's hard to know exactly, the positive uptake from the experiments, but it definitely shows that there's a difference in those cases.
I think this will be our last question. There have been some questions about where you see the future of studies of neuroscience and how it can help us understand our place in the world and connected to free will and responsibility. What do you see neuroscience helping us? What kinds of questions do you see it helping us answer?
I mean, in terms of these questions about prediction and predictability, which I think that in itself isn't the end goal, but predictability and studying the predictability of human behavior, and in particular, predicting your behavior based on your brain activity, these have very weighty implications in a lot of domains, not just in free will. I think what's been missing in the past, and I alluded to that earlier, is that we tend to look at the data when something happens, and we don't look at the data when nothing happens, which is a lot of the time, especially when you're pressing buttons or whatever you're doing in the experiment. One approach that we're starting to take is to not cut up the data according to when you move, but we just look at all the data and we treat it like a weather forecasting problem. So we're trying to build these maps. If you've ever seen these maps of the path that a hurricane is going to take, you see where the hurricane is now, and then you see this expanding cloud that is suggesting where's a probable trajectory in the future. So rather than looking at when the event happened and seeing what happened before, what we're trying to do is build a model of now and looking at how likely it is for that thing to happen in the future, in the near future, right? And build what we call like a forecast map. And that gets you around this problem of this biased selection of data where you always look at the data when some event happens, right? So that's one approach we're taking. I think another important area is just what we just talked about, was looking at decisions depending on whether they're meaningful or meaningless, whether they're consequential or whether they're consistent with your values. Does that change the way the brain activity plays out? Are different systems in the brain involved? I could go on, but I don't want to.
I'll say a little bit. So I talked a bit about capacities and how neuroscience can inform us about the nature of those capacities. But the other thing that I think maybe in terms of place in the world, so I think what neuroscience shows us is that the brain is a mechanism. We're dealing with a biological machine, and I think people have like this very strong intuition that if it's a mechanism, then it can't be free, it can't be agentive, et cetera. And I think that's where we really have to sort of change our conceptual view. I mean, there's a very easy slide from if it's a mechanism, then it can't be minded. Like that, there can't have mental states. Like, we really need to have mental states to have agency and to have responsibility. But I think there's no good inference from mechanism, therefore not mental states. And we have to learn to think about the brain as a mechanism that not that the fact of mechanism makes it impossible to have mentality, but rather that we see how mentality emerges from this particular kind of mechanism. And I think that will actually dispel a lot of the mystery around these things.